Hi everyone. This video is to show to use the Minitab for the examples we covered in chapter 10. So how to run tests comparing two means and tests comparing two variances. So we're going to start with this first example, which is recently EPA study compared the fuel economy between domestic and imported cars. At the 5% level, can they conclude that the miles per gallon is higher for imports? And we're going to assume the variances are equal on this model. So the alternative, this is a right-tail test. The alternative is that the mean for imports is greater than the mean for domestic cars. One will be imports, two will be domestic. The model, when you assume equal variances, is called a pooled variance t-test. And we have independent sampling here because we've got two separate groups, imports and domestic cars. The data is, we're going to have to assume the data is approximately normal, and we're going to assume the standard deviations are equal. So in Minitab, how we run this, and here's the data, and you can see the domestic and import cars. We're going to go under stat, basic statistics, two sample t-test. Okay, now we have a choice here how the data comes. We could either say it comes in a single, both samples are in a single column, which is what we have here. But sometimes you might have each sample is in its own column. And sometimes you could have summarized data, and you could run it all three ways using Minitab. Okay, so I'm going to click that the samples are the miles per gallon. And the categorical variable that splits it into domestic or imports are the type. And then you have to go into options. And again, we set our alternative to greater than. And here's where we assume equal variance. You have to check that box on. Okay, and so when you click OK, you get the results of the experiment. You can see the sample means are different. And the p-value is 0.038. So if we're testing it at 5%, we are going to reject the null hypothesis. I'm going to copy this back to that other document as a picture, so you can see the results of the test. And yeah, so the p-value is 0.038, which is less than alpha, 0.05. So that means we're going to reject the null hypothesis, right? And then the conclusion is going to be that the imports do have higher miles per gallon than the domestic cars. Okay? All right, so what if we decide we want to run that test where the variances are equal? And we might want to do that just by looking at the data. I'm actually going to make a box plot to look at the data. So if you go into Minitab graph and you do the box plots with groups, so we're going to graph miles per gallon by type. And when you see the box plots here, it might bring into question whether the variances are equal or not. There they are, and you can see the imports seem to be more spread out than the domestic cars. So that does kind of question whether the variances are equal. So what would happen if I ran the test assuming the variances were not equal? Okay, this is a different test. This is actually called the unequal variance t-test, or the Welch-Alpin test. Okay. So when you run the test in Minitab this way, we do the same thing we did last time, stat, basic statistics, two sample t. But now under options, we change to the assume equal variance we turn that off. And you'll notice this test is going to have less power. So we prefer to run the pooled variance t-test because it has more power. And you can see that it actually changes the results of the experiment. The degrees of freedom drop, and we have a p-value 0.051. So in this example, that actually changes the decision, right? So now the p-value is actually, p-value is 0.051, which is greater than 0.05. So that's actually failed to reject the null hypothesis. So in this case, we say there's insufficient evidence. So just by changing the test, so whether the variances are equal or not really matters. If the variances can be assumed to be equal, we end up rejecting the null. And if the variances are not equal, we fail to reject. Okay, so anyway, that's how you run those tests in Minitab. Let's go on to how do you run a dependent sampling test. So here's the example we went over in class. An independent testing agency is comparing rental costs for Hertz and Avis, and we're going to sample 15 cities and then take two measurements, a measurement from Hertz and Avis, the 5% level. Can we conclude there's a difference? So the keyword's a difference. So it's a two-tailed test, equal versus not equal. The model is a matched pair t-test, and we're going to assume dependent sampling, and that the differences are approximately normal is the other assumption. And so in Minitab, how we run that, and I'll switch over to the worksheet. And you can see on this example, we've got random cities, and we've got the two measurements for Hertz and Avis. And under stat basic statistics, it's called paired t-test. And you just pick each city, Hertz, Avis. Same thing, go to options, the hypothesized difference, leave it at 0, and just say okay. And you get the results of the test, and we'll paste that over to here. So the p-value is 0.015, which is less than 0.05, less than alpha, so reject the null hypothesis. Okay, and then we can state our conclusion that there is a difference. Hertz was slightly more expensive. Okay, and another thing you can do on this model is to look at to check for the normality. One thing you'd like to do is to actually graph the differences, and in that same command, and I'll go back to it, stat basic statistics paired t, you can make this graph, a histogram of the differences. So I'm going to do that. Or you can make a box plot as well, but let's just make a histogram and see what it looks like. And that's supposed to be normal. And I don't know, we got a couple outliers, but I guess if you didn't have the outliers, it'd be normal. But those, under the null hypothesis, the assumption is the distribution of these differences should be approximately normal. Okay. I have one last model I want to go over from this chapter, which is comparing two variances, and this is that F-test. So I'm going to use that same data with the EPA study, because we had to decide whether the variances were equal or not. If the variances were equal, we rejected the null hypothesis for the t-test. But if the variances are not equal, we failed to reject. So the variance test is pretty easy to run. The F-test is pretty easy to run in Minitab. You go again back, I'm going to go back to that original data here, the domestic import cars, and it's under stat basic statistics two variances. So the samples again are in column 1, and the IDs are in the type of vehicle, domestic or import. And again, this has this same split. You actually can enter sample standard deviations or sample variances. Doesn't matter. So I'm going to go to options, set my alternative as not equal to. And here, you check this box. To get the F-test, you have to check this box to assume the data is approximately normal, which I will. Okay. And then when you click OK, you get the F-test right here. And you can see the p-value is 0.044. Right, so I'll copy that and come back to the problem. And I'm going to test this, it doesn't say, but I'm going to test this at a significance level of 5%. Right? And so you can see the results. So let's just say, we're going to use the same alpha we did in the original problem up top. So the p-value is actually 0.044, which is less than alpha. So that means we're going to reject the null hypothesis, which means we have to assume the variances are not equal for purposes of so we have to assume, so our conclusion is the variances are not equal, right? And we're going to have to run the pooled variance, the unequal variance t-test for comparing the two the miles per gallon. So variances are not equal. Okay, so that's how you run these tests in Minitab, and you should be able to do the lab.